Welcome to our Fire Up Weekly Wednesday webinar sponsored by Newfields Ag, where we bring innovations in your fields. We encourage you to visit our full service website at newfieldsag.com, where you will find a complete listing of Newfields Ag products, product descriptions and videos, use and application instructions, contact information for your local dealer, pricing, and much, much more. I want to thank each of you for registering and joining us this morning. If you have a question during the presentation, please place your question in the chat box or simply raise your hand and we will get it asked. I'm your host, Bob Kessler with Newfields Ag. Today's focus will be on Bolst-R. It's Newfields Ag's new planter box N fixer product for the 2025 season. We're excited and look forward to our new partnership with New Life Bio, where we source the components for the Bolst-R product. Joining us to share his expertise this morning is Dave DePeppo. Welcome, Dave, and thank you for joining us this morning.
Thanks for having me on today. As I go through this, if you guys have questions, you can stop me or ask like they said, or I can take them at the end and go back and cover some things. Bolst-R is a consortium of bacteria that's designed to work in synergy to increase availability and plant uptake of N, P, and K. And most strains of bacteria don't just work and do one thing when they're in the soil and in the plant. They do multiple things. So those would be the focus. Those would be what we source bacteria to focus on, but you're going to get a lot of other benefits from having the bacteria in the soil. And so I have my picture here is like a bunch of bacillus bacteria in a consortium. We source and grow bacteria that work together, and we put our bacteria through a lot of testing to understand what they do well, how they can complement other strains of bacteria, and how they work together. And so as I go through this and explain kind of how bacteria grow and the things that are going on in the soil, all of the strains we have work together to deliver the results that we're looking for in the soil, in the plant, and in the whole system. So this product has 4 strains of bacteria that work to fix nitrogen from the soil, from the air, and move it into the plant. So it'll help the plant assimilate the nitrogen and efficiently utilize it. There's one strain that works with the rest of the consortium to solubilize phosphorus and make it more plant available, and one that works for potassium. And so as a package, they all work together, and as they're growing and doing things, they're not just doing one thing, but they're supporting the life cycle and function of all the other strains as they work together. So one of the things that makes these bacteria very, very hardy, very durable, have a really long shelf life, is they're delivered in the endospore form. And so when bacillus bacteria, when they're forced into a situation that they're not going to be able to survive, they form an endospore, which is like a seed. So if you kind of think of it as a corn seed or a wheat seed, it's alive, but it's not respirating, and it can survive for a very long period of time. Archaeologists find bacteria that they can bring back to life in situations that's been dormant for thousands of years. So the things that bacteria needs to start to grow and come to life is it needs a usually we're putting them in the soil, so they need to know they're in the soil. They can come to life in a solution if the right things are there. Like in our lab, we can plate them out in a solution, or, in a lab, you can do that. But most of the time, they can sense they're in the soil. They can sense that they have a food source so that they can start to grow, and moisture and the temperature. So those would be the things that, until they have all that put together, they're fine. So treated on the seed, no problem. They have very long life that way. In the package, no problem with that. And so we're delivering the bacteria that are encapsulated in the dust particles, forming the product, and we're providing over 300 billion CFUs per acre. And that's really important to have high colony forming units. That's what CFUs are. And that's to give the consortium a good chance to start growing and having dominance in the soil, so that they're the main bacteria that are going to be working to colonize the roots of the corn plant and to deliver the results you're looking for. So the main way that Bacillus there's thousands of strains of bacteria, but Bacillus is mainly what we're working with today. And the way that they grow is through a process called binary fission. And so that's kind of in this picture here. You can see in about every 45 to 60 minutes, one Bacillus bacteria will divide and make two. And then in the next hour. So if we deliver over 300 billion colony forming units to the soil, then in an hour we have 600 billion, and pretty soon we have trillions. And it doesn't take very long to have very, very high populations. And because we're delivering this product in the furrow with the seed, we're growing the population all around the corn roots. As the corn plant grows, we're delivering the strains of bacteria that the corn needs. So when bacteria start growing, they need a food source to start growing. They don't always have to be delivered with a food source. There can be a food source, in the soil that they find, but if you deliver them with a food source, that they start growing faster. So the two things that a food source does is, as they start to come out of the endospore and grow, they need different components so that as the one cell splits into two, they can rebuild the cell walls and grow. The other thing is, when they start to grow, your bacteria is coming out of sporulation the same time your seed's germinating and starting to grow. So maybe you have that 4-7 day period before you really have a lot of roots starting to grow for the bacteria to colonize. So the food source also gives them a place to start to colonize, and grow until the plant starts to grow roots to colonize on the roots. So those two things are pretty key. And because the dust is soy based, it's loaded with amino acids, which are a great food source for bacteria to start growing. So you've got advantages of the amino acids in the soil with the dust, and then you've got the amino acids as a food source to kick off your bacteria, and then you've got your season-long bacteria delivering nutrient use sufficiency to your corn plant. The bacteria, I think it's important to go over that. To me, like a lot of times when people talk about in furrow, they think of a product that is going to work from germination to, say, V3 or something like that. Historically, like an in-furrow fertilizer, they think that's going to be to get the plant off to a good start. But when you're putting bacteria in furrow, you're giving the plant season-long control. So the bacillus bacteria have what they call flagella, which are those looks like a tail on the bacteria, and they spin counterclockwise and they can propel the bacteria through the soil. And as the plant grows, the corn plant's going to secrete sugars and exudates, which are chemical signals to tell the bacteria to come and colonize on them. And actually, as the corn plant grows, the chemicals that they're secreting actually tell the bacteria how many pounds of nitrogen, how many pounds of phosphorus, how much, what they actually need for that day. It's kind of like giving the guy out in your warehouse a list of what to load on a truck. The corn plant's telling the bacteria, hey, this is what I need for optimum growth today. And then the bacteria are trying to deliver that to the corn plant. And so as the corn grows, the bacteria continue to colonize. So these bacteria are going to continue to colonize roots all the way up until dent, probably. I mean, whenever you get, like, the corn plant shuts down and you get pretty much zero or more root growth. So it'll probably slow down as it gets into the reproduction stages, and the root growth is a lot less than it is up to that point. But as long as the corn is still has activity in the roots, it's going to continue to call the bacteria. And as long as it's still trying to fill that ear, it still has high levels of nutrient requirements through grain fill. It's going to continue to motivate and try to work with the bacteria in the soil. So the strains of bacteria they will also colonize on organic nutrients in the soil. And we've been told a lot of different things throughout our careers on what's available in the soil. And if you go back to when I was in school, we had the Bray phosphorus test, and they said the P1 was available and the P2 wasn't. And no matter what you did, that ratio was going to stay the same. Well, it can change with biology, and it can change with soil health. And they're adding biology to the soil is a great way to jumpstart and to increase soil health. There are other things that you can do that take time on a farm that you can do to increase your biodiversity in the soil also. But the problem is that a lot of the nutrients in the soil that we would have called organic nutrients years ago, and when we were in school, they have carbon attached to them, and plants can't pull carbon in through the roots. They pull CO2 in through the air. And so the bacteria naturally in the soil break that apart and so you have carbon, oxygen, and phosphorus. The bacteria that are in the soil break that apart, and you end up with H2PO4, which is plant available phosphate, and CO2. And that process, depending on the levels of bacteria in your soil and the quality of the bacteria, is how well that's working. And it also has a lot to do with your farming practices and the different, I don't have enough time to go into all the soil chemistry that goes on, but so that as the same time that the bacteria are colonizing the roots and they're helping move nutrients in and out of the plant, also you have bacteria colonizing on organic compounds in the soil, plant residue, trying to free up and make more nutrients available for the bacteria to move in and out of the plant. And the only nutrients that plants can pull in, corn plants, it would be something in the pure ionic form, like ammonium. They could do that without bacteria, but because we have positive and negatively charged nutrients in the soil, most of our nutrients are stuck to other things, zinc and sulfur, zinc and phosphorus, and so the bacteria are able to pull those apart and get them into the right form to move them in and out of the plant. So the other thing is a lot of times I think in my head, I kind of think in one dimension. And if you can kind of go with me for a second and think of the bacteria in a multi-dimensional way. So all the stuff I just showed you, so from when the first bacteria comes out of the endospore in your soil and it starts binary fission, it's going through its whole life cycle and it's doing a lot of things all at the same time. So it's moving to colonize, it's producing organic compounds, it's producing enzymes, proteins, soil surfactants, and these are things that the other bacteria consume and use, and they also benefit the soil. So enzymes are how the bacteria is able to break the ionic bonds and free and work with nutrients. Enzymes themselves last, minutes in the soil, but because you have high amounts of bacteria continuously producing enzymes, you have a season-long supply of the enzymes to do the work that you want to get done. Surfactants help with your soil aggregation and your pores, and to have a healthy soil, you need um, a well aggregated soil, and so you need pores for water penetration, for air to be in the soil, for earthworms don't have augers on their forehead. So if you want the other critters that live in the soil to be there, they need a lot of pores so they can easily inhabit the soil. And so all these things come together as benefits as the bacteria are growing and they're moving all around the root system of that corn plant. They're also providing this benefit in your soil. And you'll see this over time that this will continue to improve. Um, when you're looking at bacteria, it's not the same as looking at like a generic chemical. It's not like you can look at atrazine and you can have 10 labels for atrazine, and the difference is the manufacturer's formulation process. The active ingredient, if you can deliver it to the soil, does the same thing from every company, but you might have a formulation that's easier to spray or that mixes better. With biology, it has a lot to do with how the bacteria is grown. And if you kind of, as you start to look and dig around in the world, there's bacteria that we know that have soil and plant benefits. They also can be an insecticide or they can be a fungicide. And so how a company grows bacteria has a lot to do with how they perform. And so if you think maybe like there's genotype and phenotype, there's a lot of bacillus bacteria. There's a lot of, say, a bacillus subtilis or a bacillus licheniformis, but all of them don't do the same thing. So if you have 5 labels for a product that has the same strain of bacteria, they may not all perform the same. And so just something, I guess, to consider when you're out there. And our bacteria are all grown from parent material. So they're what we when Newfields requested a consortium to do a certain thing, they're the bacteria that we represented in that. And every batch that we grow starts from our library of bacteria from U.S. soils. So that's kind of a quick rundown. I guess you guys have any questions or anything you want me to get into deeper?
So are there any questions out there from the group?
Hang on. David Runyon here.
Hey, Dave.
Yes, I have a question. Does your dust dry product, does it have cytophores in? And with my understanding is cytophores are supposed to help for vomitoxin. Is that all? Do you think that's true?
So the siderophores are not in this product. The siderophores that we have available to us come with our combinations of the Terrasym 450 products. DePeppo, leave your slides up with you.
Okay.
As we move into that, there are several things that the siderophores are good at and that can help with. And I think we're like Dave covered in this presentation, we're still learning every day what the interactions of the different bacilli and other microorganisms do in the soil in this interaction. So that's been the really interesting part for us as we move forward. So yes, I think to answer your question, yeah, there are things that are going on within that system that we don't fully understand. And that in this product, we do not have a siderophore option.
Okay.
Thanks for the question, Dave.
Thank you.
Yep.
So there's a question in the chat box. So as I understand, Bolst-R is an exophytic product that lives on the roots. Does he have that correct?
It lives in the soil, on the roots. It goes into the roots and is in the plant. So bacteria, if you kind of could think of them maybe like a forklift in your warehouse, they do multiple things, but they free the nutrients from the soil. They also get them in the right form, and then they move them in and out of the plant. So the same ways that a plant pulls nutrients through root interception, mass flow, diffusion, bacteria are involved in all those processes to make sure that as your nutrients get in the soil solution, they get near the plant, the bacteria are kind of shuttling them or moving them in and out of the plant.
So Dave, Newfields Ag offers different forms of end fixing products. We have this dry product that can be pre-treated ahead of time. It could be put in right at the planter box. We've got a wettable powder. We have liquid end fixers. As far as timing is concerned, in your opinion, is it better to get this product on as early as you can, or through your research, does it not really matter? I mean, if you put a foliar product on it, it's going to be as effective as getting it right in furrow on the seed.
I guess that's a variable question depending on the rest of your management plan. Generally, so you don't have a huge need for nitrogen up front, but you're having the bacteria in the soil gets this whole process started and working so that it's ready to go. The corn, it's delivering to the corn plant. This would be kind of, to me, I mean, you have the different option. If you could have this in your soil in your field, and you could still put a foliar nitrogen option. Or if this for some reason isn't in your plan, you could come back with a foliar. I think they're both, they both work. It just depends on your farm management, I guess.
Right.
Me personally, I always like to start. My experience, I was an agronomist for 16 years in retail. I always wanted I wanted the best chance to have the best crop to always start at planting.
Right.
One of the things this is Brian, one of the things, Dave, that you touched on is the fact that this is not a single strain product that we went out and picked. We picked a product with y'all's assistance that has a nutrient use efficiency model. That's been one of the things that Newfields Ag has prided itself on, is the fact that we have diversification. And so you have 4 different strains of nitrogen fixation, but you've also got a P and K piece in there as well to try to do that full component of it. So like you're talking about, being in there early as the plant starts to germinate and starts its struggle to come out of the soil, giving it the ability to access this and have the nutrients in that rhizosphere be made more available by the inclusion of this product are what we've seen in the testing and the studies that have been done over the last 4 or 5 years with this product that interested us in bringing it out is that very thing. The increase in early plant vigor, the increase in ultimately yield, but the use of the nutrients that are available to the plant in that rhizosphere where it is. So that's why we developed it with y'all, is because of that, that very issue.
You're gonna see, if you start to think about your soil chemistry, I'm guessing most everyone on here has made recommendations, but like, in order, you're gonna have these bacteria working on sulfur, because a lot of the stuff that they're coming in contact with is nitrogen. It's got sulfur in, or it's phosphorus. The different, with potassium, you've got calcium, magnesium, so there, it's not like they just do one thing. We've just selected ones that are really good at the things that we're looking at, but they are doing other things in the soil at the same time. So that would lend to having it on early to get the maximum benefit of everything that you're trying to accomplish. Because you do need phos early. That's the critical time. Emergence through B5 is pretty key to have a good supply of phosphorus.
Any other questions? Any other comments from the group?
Thanks, Dave. It's a good explanation of the process for us, and also giving an overview of our relationship with and why we chose to partner with you and New Life as we develop these new products. So I appreciate that.
Okay. We have one question. One question here, Dave. Just best placement for the product.
In this one would pretty much be in furrow. I mean, it's
planter box.
Yeah, planter box. It's
pre-treated planter box. It's a dry product.
Yep.
Dave, what's your best guess on shelf life?
We say 5 years for the market, but we have stuff that's over 10 years old that's fine. So once we have a dry product, it's very long shelf life. And as far as treated on the seed, there's nothing in the seed box or the seed tender or where you're storing the seed that would pull the bacteria out of endospore. There's nothing there that would ever. They could stay that way for way longer than you'd want the seed to sit around.
All right, here's some more question. Will Bolst-R become so-called lazy in a high phos, high nitrogen environment?
No, I'm not. If I'm thinking on the same,
it'll keep working, right?
It's probably going to work harder, because most of the time, just thinking of like soils I work with in Iowa, you have a lot of nutrition there, and I don't know that a lot of it's always available to the plant. In different soils, you're going to see different results. The whole supplying nutrient to the plant you're still coming down to what your limiting factor is. You know, if you think of that barrel with the different staves, and so hopefully by having the bacteria right as kind of a foundation in your soil, we have bacteria in our soils, but if you think about like all of our major corn growing farm ground was prairie grass. That's what the native soil was when we broke it out and started farming. You know, our great grandparents used to grow corn and wheat and potatoes and clover and all kinds of crops, and they had a lot more biodiversity. We've selected different strains of bacteria over the years. I don't know that we ever had bacteria that were geared to raise 300 bushel corn, or, you know, and I think that we've also done a lot of things to cause, you know, different bacteria populations to not be as good. So I think if you over fertilize and if it's all plant available, that could maybe be the case. But I just don't think that it's, you know, the fields I'm thinking that are high in phos have got some reason that it's not available, or they're heavily manured, and those are places where a product like this is going to really help.
So Brad asks, and maybe I'll ask Brad to expound on this a little bit, because it's a kind of a 35,000 foot question. What system or soil would give us the best chance for improved yields? Iowa soil versus Arizona soil? Is that what you're talking about? Or so what system or soil would give us the best chance for improved yields?
Yeah, Bob, I was just looking for clarification on placement. You know, if a guy could only use it on a certain number of acres, or do you want that on the lower performing acres that maybe would have a hard time, you know, accessing phosphorus and potassium? That'd be kind of my guess, but just kind of wanted you to confirm that.
If you have a challenge, I mean, you have to have phosphorus in the soil to release. So I have seen, you know, soil tests. There's pretty depleted soils. If you get into really low organic matter sandy soils that are, you know, heavily farmed, pivots in some places, they need a lot of fertility because they don't have much. But if you have fertility that's stuck in your soil, that'd be a good place. But what I think you're going to see is even in our better soils, we still are not utilizing, you know, we're putting on 50, 60 pounds of phos every year, where a lot of people put crop removal down, and we're building soil test levels where I don't think we're accessing all of the nutrition in the soil. So I think if a farmer had 500 acres and they were only going to buy 100, I'd probably put it on their acres that they were asking for help on. But I think it would work good wherever you wanted to put it. We're seeing positive responses to different strains of bacteria across the Corn Belt, where we have some of the best soils.
So what I found. Go ahead, Brad.
I was going to say, I'm looking forward to trying it, having all three modes of action, plus, you know, a bunch of other things that it does there, plus the aminos. I think it's going to be a great product. So I'm looking forward to trying it this year.
So Greg comments, last year he saw the Terrasym work best on lower organic matter acres. Will this work the same, acres that have maybe less microbial activity?
Yeah, I mean, if you are really short on bacteria, that's definitely, it's going to shine better in that situation.
Yeah, and this might be a Brian question. Dave asks, will your seed treatment ever penetrate the seed coat, or does it just stay on the exterior of the seed? Say if it sits there for a long period of time.
So we've not seen that happen. We've learned never to say never on anything, but all of our testing over the last 8 years has seen that we do not penetrate the seed coat. It gets back to what Dave said in his presentation, that until the plant is germinated, we don't see anything that activates that biology so that it would start. We manage that with our dust component, so that we can encapsulate the biology within that soy protein and the amino acids there, so that we can protect that and have a shell, a cocoon around that, so you don't see it actively. So this is not like an inoculant that is sprayed onto the seed, where you can see that this is actually encapsulated and gets into the soil, and then the solution around that rhizosphere around the seed is when it gets activated. So that's how you see it being able to be on seed so long with no negative effect on germination.
Yep, I would agree.
Whew! Glad I answered that right, Dave. Thanks.
Always good to get it verified.
Exactly.
So Dave, one of the things that I found interesting in your presentation is that, Newfields Ag is marketing this as an end fixer, right? But it really does a lot more than that. When you ask somebody that is saving for retirement, one of the questions they ask is, when should I start? And the pat answer is, as soon as you can, right? Start right now. So I kind of see soil as the same thing, soil health as the same thing. When should I start improving my soil health? And if we can get guys to think about not farming for 1 year, but for farming for next year, the year after, what they're doing today affects what their soil is going to be in 2, 3, 4 years. I think a product like this goes towards that. If you want to start improving your soil health, start now. And something like this is not only going to have bacillus in it for the end fixing capability, but it's going to start improving your soil health, for your crops down the road as well. Do you agree with that?
Yes. There's obviously bacteria in the soil most of the places. I mean, there are fields here and there that have been abused so bad that they hardly have any life in the soil, and you would know those right off because they would be very low producing fields. But whether I'd say everybody on this call is probably caught and thrown a football, but that doesn't mean we're all ready for the NFL. And so when you have bacteria in the soil, you can have bacteria that's able to fix nitrogen or to solubilize phosphorus, but they all don't do it the same. And, through our testing, we have a library of bacteria that we know, we've rated them all on how they perform and how they work with other species. And that's really a key here is having high populations of bacteria that what they do, and they're going to help you get your yield ready. It's kind of like if you live in an area with low pH, you need to lime the soil to get everything else to go in the right ratios so that you can have nutrient availability. You need to know you have the right bacteria so that everything else you're doing to that crop, your hybrid choice, the rest of your fertility, any other plant growth enhancing products you're using, all that stuff works good because your plant's growing at the best way it can.
You had mentioned earlier about manured acres, and it works really well on highly manured acres. Can you explain to us why that comment is true and how it works and does it make more phosphorus, more potassium available than is actually available?
Generally, when you put a lot of manure in fields, you do two things. You have a lot of nutrients that are not always available. If you go back to like, newer manure recommendations we learned in college, a certain percent of your each nutrient's available the first, second, third, fourth year after an application. The other thing is it throws a lot of the ratios of the nutrients out of whack, where like a zinc to phosphorus ratio that you would find might be like an 8-to-1 or 10-to-1. And in manured fields, you start to see a lot of that stuff depending on the type of manure, how much you put on, the form it was in when it was applied. You can have a lot of different micros and macronutrients, but because of soil conditions, they're not available. And bacteria is what has to break that down. So adding bacteria is going to speed up that process versus just waiting for it to naturally happen, especially if you don't have enough of the right strains in your soil to deal with what you've done to it.
Okay. Good questions. Good questions. Well, thanks, Dave. We appreciate
Okay.
your presentation and your comments and your advice. Thanks for joining us today and helping us understand this new product a little better. For the group, we encourage you to visit our website, newfieldsag.com. Again, also check out our podcast, Innovations in Your Fields. It's available on Spotify as well as Apple. Just go in Innovations in Your Fields and you should be able to find our podcast. Thank you for joining us again today. As always, we hope to see you here next week when Newfields Ag presents another Wednesday webinar. I believe next week is going to be on our BioStealth with Provider PM, our CRW product. So please join us for that. Be safe. Have a great rest of your week. Thanks again.